Okay, so now we get into some of our more formal discussion topics. And the first one is around the importance of a geospatial reference system. So this is about the why. How do we explain why this is important to decision makers? And you'll see there I've got our acknowledgements from people from all around the world who helped Ryan and I put this particular presentation together. So thank you for the contributions from all those people. So what is a modern geospatial reference system? We're going to have a brief discussion about that. Then we're going to look at what does it enable. We had a quick chat this morning about the components of the reference system. We'll look at some of those in a little bit more detail. And then we'll discuss how we can explain a geospatial reference system to policymakers. So I won't go through this in too much detail again, but this is just a reminder. This is showing all the different elements of the reference system, whether it be static datums, time-dependent datums, or height datums. And if I can just get a quick show of hands, I would be interested to know who thinks they have a reference system. So when I say modern, I'm talking about let's say a static datum that is linked with ITRF. Can you put up your hand if you have that in your country? Static datum that's linked with ITRF. It doesn't even matter if it's an old version of ITRF, but it's linked with ITRF. Okay, so thank you for that. Those groups, those countries that have that, what it enables you to do is you're in the same reference system as ITRF, you're in the same reference system as the Global Navigation Satellite System. So the information you collect from satellites, you're broadly in the same reference system as that. So it allows you to capitalize, to make the best use of those satellite observations, whether it be remote sensing or GNSS applications like position, navigation, timing applications. If you don't have a reference system linked with ITRF, it doesn't mean you can't do it, but it's an added level of complexity. So what we're looking to cover throughout this week is to provide guidance for countries who may not have a reference frame that's connect with ITRF and therefore linked with satellite observations. How do you develop something like that? But there may also be those countries who do have one that's linked with ITRF. You may want to make it more up-to-date, more modern. And to give you an example, this is something that we did in Australia because the old datum that we used was linked with the International Terrestrial Reference Frame of 1992. And the difference between ITRF 1992 and ITRF 2014, which was the one that we chose, was about 9 centimeters in the ellipsoidal height. So there are these improvements and refinements that happen to ITRF over time. And 9 centimeters, you can imagine, particularly for offshore applications, that can be quite a big issue. So having your reference system in your country aligned with the most modern version of ITRF has these efficiencies and advantages. So even if you are one of those countries who put up your hand, there may be an opportunity to think about how you could modernize it and even make it more current. So what does it enable? If you have a geospatial reference system for your country, what it enables is accurate positioning and navigation applications, as I mentioned. It also helps with data integration and consistency. It gives you a better understanding of how to transform between different datums. And it also allows you to do better spatial analysis with high accuracy. So this comes down to those GIS applications that many of you would work on in your offices or you get asked to prepare information about. It allows you to bring that data together with a higher degree of accuracy. And then finally, as I mentioned, by having a reference system aligned with ITRF, you're then also in a better position to do the real-time usage of that satellite data. So a geospatial reference system actually underpins the collection, the management, and the alignment of that spatial information to help you make better decisions. And you can think about, look at the layers on the right-hand side. I'll read the titles out because I know it's hard to read from where you are. But that base layer is your positioning layer. That's your datum for your country. And if that is accurate and reliable, on top of that, you have layers like imagery, roads, property, addressing. You could have more environmental layers. And then you could also have things like natural hazard information, as well as business locations. And you can see on the top, there's satellites that are giving you your position. So if you're collecting all that data in real time and all that data is spatially aligned, it allows you to, it opens up a whole range of different applications that you can use. So this is some of the story, some of the narrative that you can use to explain to policymakers to show the benefits of aligning all of this data. Thank you very much. So here's an example of this is a bushfire example. And what you can see in the middle in red there, that's a burn scar. So that's where the forest fire used to be. And that's where it's come from. And then the bright red bit in the top is where the current active fire is. And then on the left-hand side, you can see the red cross. That could be a fire unit. And that's so a fire truck or something related to the fire brigade. And that's traveling at 75 kilometers an hour on that road. And you can see the location of the buildings in yellow. And you can start to see that if you are a fire controller, this gives you information to make decisions in real time about an active fire front. So you can make informed decisions and guide people how to move safely or guide the fire brigade as to where they need to be to try and attack the fire. If we consider the example though, where these data sets are not aligned, where they're all in their own unique reference system that's not connected, it doesn't allow you to make this decision. The roads layer, the emergency services layer will be using real-time GPS, but it's clear that the roads information, the buildings information, the remote sensing imagery and the burn scar information are all on different layers. So you're not able to make an informed decision using multiple data sets. The stories like this can help you explain why you're trying to transition from an old datum in your country if it's not connected with GPS or ITRF, and why you would want to modernize and move to a new static datum, which is shown at the top. And then you need to develop your transformation parameters to go from one to the other. And that's what's shown here. So we'll have a presentation or two. It's either later today or tomorrow where we'll work through what these transformation parameters are and how you can develop these for your country to move towards a new modern datum. Some of you will be familiar with this. I heard there are a few professors and associate professors in Geodesy. I'm sure you teach this to your students. To transform between two different reference frames, you need to know a bit about each of the reference frames. And so you can see this is a 3 axes where the dot in the middle of each of those diagrams is actually the center of the Earth. And then we had a Z coming out the top and an X and Y out the sides. And what we're showing here is you've got 2 different models of what the Earth would look like. So 2 different reference frames. And we can map from one to the other by working out similar, if you go to the same point on the Earth's surface and you collect information in 2 different reference frames, you then can create a connection between those frames. And we'll work through an example of how you can do this with your data sets. And what it allows you to do is come up with these 7 parameters: the translation, the rotation, and the scale of the reference frame. And then you can rotate and transform between one to the other and transform your data from one reference frame into another. We also talked a little bit about this need to connect with the International Terrestrial Reference Frame. That's a time-dependent reference frame, as shown there on the top left. The necessity for that and the connection with your own static datum in your country is because the ITRF and things like WGS84, which is another time-dependent reference frame, these these will change over time. So in many countries, there's sort of centimeters a year difference between the static datum and what happens with the time-dependent reference frame due to plate tectonics. If you look at Australia, we had a particular problem with this because the Australian plate moves at 7 centimeters a year. So very quickly, over the course of, since we'd had our last datum, which was about 20 years old, we saw a 1.5 meter difference between GPS coordinates and what we had in our own static datum in the country. And you can imagine in Australia, where we were using, a lot of people were starting to get accuracy, centimeter accuracy GPS observations. They were starting to see this discrepancy between what the old datum was showing and what GPS was telling them. So this is very confusing for a lot of people. So we needed to update static datum and then create this alignment with GPS so that we could keep it up to date over time. So you can develop models to switch between it. And then the user doesn't even notice that this is happening because it's all happening in the background. But you, as the spatial professionals, you can create these models and transformation parameters so that it's all happening in the background and the users don't even recognize this is happening because you've done all the hard work. This just shows you the complexity of the reference frames around the world and the velocity models. Some of you might know Zahir El-Tamimi. He's been involved in helping with some AFREF discussions in the past. Zahir, I like to call him the godfather of modern geodesy. He's the person who puts together these international terrestrial reference frames and has done so for a very long time now. And here's his velocity model that shows the movement of each of the continental plates. And you can see in Australia, it's fast, but it's largely in the same direction. But then around the border of Australia, you've got arrows going in lots of different directions because you've got continental plates ramming into each other from a whole range of different angles. What we would like to do, if you have a look at the left-hand side of the picture, is try and increase the number of observations that we have from that Africa region to give us a better understanding of the plate motion, but also the intraplate motion. So how is the internal plate deforming? And then how can we use that information to try and improve the datums and the reference systems used throughout Africa? And we'll come to the height component on Wednesday, a bit later in the week, but looking at what is a current modern height datum look like, and how can we develop geoid models or height datum models to move between the geometric frame, which is your static datum, and the physical height datum, which is based on how water will flow over a surface, and that's not always the same as what you'll get with GPS observations. So we got to make sure that we have a height datum that's based on physical geodesy, it's based on gravity observations. That's very necessary in a country. We can't just rely on having a static, having a geometric datum like an ITRF-based datum, because that's geometric. It doesn't actually conform to how gravity is going to move water around. And my old boss in Australia used to use the analogy that if you are going to create a height datum for your country, all you need to think about is the sewerage system. That's the way you explain it to a politician, because you don't want to have a sewerage system that's based off geometric observations, because sometimes the water will flow uphill and no one wants sewage flowing in the wrong direction. So as soon as you explain the difference to them in ways that they can understand, hopefully that might result in you getting some extra money to pay for things like gravity observations and to improve the quality of your gravity data and your height datum in your country. And we'll talk through some of this and the differences between them later in the week. Importantly, there's not just those technical parts. There's not just the models, not just the datums, but we also need these threads that run throughout it. And that's the standards and the software. That's a very important part of your geospatial reference system in your country. You need to make sure that you have the standards required to ensure the geodetic information is findable, accessible, interoperable, and reusable. And a good example of this is the ISO Geodetic register, where you can store information about your datums and your transformation parameters in an authoritative way. So the ISO Geodetic Register only records the information that comes from the member states that says this is the authoritative way to recognize position in our country. There's also great products out there like the EPSG register. Many of you would probably know that who use GIS software. That's been around for a very long time. There's some great information in there. It's just not authoritative in the same way that the ISO Geodetic Register is. There's more information in there, and sometimes there's multiple types of information, and you don't know actually which one is the correct one. So there's a description. There's a difference there that we need to consider, and we'll talk about that more later on. So the geodesist really develops the datums and the transformations that make this technical information available in a standardized format so that software developers don't need to be specialists in geodesy. They can just adopt the standards and practices that you put in place. And then it means all the users of the software are able to use it accurately and reliably. As I mentioned, this abstracts or takes away the pressure from the user. And I think that's really our key role as the geodesists or the geospatial experts from your country. There's also laws and regulations that are important. So as I mentioned, when we went through this process in Australia, the technical part was, yes, it's challenging, but it wasn't the most challenging for us. The most challenging was dealing with the coordination across different states and territories and the federal government, looking at what laws and regulations would be impacted by updating the datum. You can create a new technical datum, but getting it implemented in laws, in particular for land administration, can be very challenging. So you need to engage those people very early on in your discussions. That's where the real benefits of a new datum come from. It's the users who see the benefits. It's not you as the geodesist or the surveyor. So if you're going to go to all the effort of doing all this work, you want to make sure that the industry bodies and the other government departments are aware of what you're doing and they can benefit from the result. And then finally, people. None of this happens without people. And there are key people we need involved in the process of modernizing the reference system, but we also need to be thinking about capacity development and how do we ensure that there is the next group of people coming through who can take over this work into the future. It's also important to know that this is not a new idea. The idea of upgrading a geospatial reference system is nothing new. Over centuries, people have worked through many phases of upgrading their geospatial reference system, and it's always based on the needs of the stakeholders. At least it should always be based on the needs of the stakeholders. Sometimes it might be because you've got a geodesist in your country who thinks, well, this is more accurate. I just want to do it this way because it's more accurate. That's not really a good reason, and it's unlikely to get a lot of political support. You need to describe how it is going to benefit the community. And so some examples they've got shown this. Thank you to ChatGPT for generating this for me. But it started off as things like scientific exploration, and you think about trade and maritime navigation. There was need to understand how big the world was and where countries were. And then it's about mapping of boundaries of countries. And unfortunate, but military applications are a big driver for improvements in the accuracy of our positioning technology as well. And nowadays we have satellite positioning and satellite applications. So you can see that use case that I came back to from the start about we have so much free and easily accessible satellite information that we can collect nowadays. By moving your reference system to align with those satellite systems, you get to make best use of that data and make great efficiencies from it. So here's an example that one of my colleagues from Australia presented in a meeting we had in March, and I've picked out a few of her slides to talk about how they describe this to the government in Australia when we were looking to get an upgrade for our reference system and our positioning capability. And it was really about developing an integrated national positioning capability to accelerate the adoption and development of location-based technology and applications in Australia. So very user-focused. As a result, it came down to getting $1.4 billion over 20 years. And this was not just for ground-based technology, but a new satellite-based technology for an SBAS. And some of you might know what an SBAS is. It's a high integrity signal that you get. It looks like a GPS satellite signal, but it's actually a high integrity signal. It tells you, can I trust GPS at this time or can I not trust it? And it's heavily used in the aviation sector. You probably heard a little bit about jamming and spoofing. This is something where it tells you, can I be trusting the GPS signal at this time? And for aviation and maritime safety, something like that is critical. And we didn't have one of these in Australia and New Zealand. So they partnered together to develop this concept, and it got funded by the government. But it also led to improvement in our ground observatories, and it led to the upgrade of our geospatial reference system. So we put all this package of work that needed to be done together and talked about how by doing this together, it was going to be of benefit to Australia. And here's some examples around the road sector. Cooperative intelligent transport systems are growing around the world with the need for things like 3D digital mapping, for automated cooperative systems, vehicle speed determination for regulatory compliance, real-time road pricing. This is happening in a range of different countries. In terms of general aviation, I mentioned the airport and airline sector. The biggest users and biggest use case of this in Australia was for regional airports. It's not about the big airports, but it was about areas where they don't have a lot of radar technology on the ground. So they could trust GPS more to help them get into landing strips where sometimes the weather wasn't very good and the pilot couldn't actually see the ground because they couldn't get below the cloud. Now they're allowed to go below the cloud to a greater extent using GPS, and then they can see the runway and come in and land. So for like the doctor's service that they use for remote Australia, this was a very useful application. The rail sector is another key user. Construction, they're looking at having buzzers in helmets to help identify when there's other trucks or dangerous goods around that could hurt people. So your helmet starts buzzing to alert you that you should be looking around and make sure you're not in danger. Drone technology is growing ever more, not just for imagery, but also for things like deliveries of packages. And an interesting one that I didn't see coming was livestock and agriculture. They're talking about virtual fencing for cattle. And this was an example that was extremely important for one of the senators we had in Australia, because he is the senator for an area where this is costing people a lot of money. So coming up with use cases that talk to the minister who is responsible for the things that you want to get money for, if you can cater your use cases for them, sometimes it can be of great advantage. And obviously the mining sector is very big in Australia as well, as it is throughout other parts of Africa. So there's opportunities to talk about the efficiencies you get from having GNSS based datum in your country and being able to use GNSS technology for greater efficiencies. And there's also use cases of how you can help consumers. We had an example of people who are visually impaired, if they can use augmented reality to help them navigate. Social things like this, where you can connect a person with a story, speaks to decision makers a lot better than just talking about reference frames and technology. Being able to personalize a story and talking about the social impacts is vital when you're looking to get more money. The maritime sector was very big. We mentioned before around this 9 centimeters difference between our old datum and the new datum. You might think that's not much, but if you look at this one particular port, having a better understanding of your height, in this case, every extra 10 centimeters that you had in Port Hedland in Western Australia equates to $200 million of iron ore exports every year. So you think, well, changing my datum by 9 centimeters, does it matter? Well, at this one port, it matters by about $200 million a year. So you can demonstrate very quickly to the government that this investment is going to pay for itself very, very quickly. Coming up with these use cases, that's the hard part. It's not technical, it's all stakeholder engagement based. But once you have this information, it's extremely powerful to help you get the funding you need to do the work that you want to do in your country. All right, so we've covered what is a geospatial reference system. I hope it makes sense now. It's not just one thing, it's a collection of different models and tools and datums and people that come together to help you develop accurate positioning and navigation capabilities in your country. We've talked about what it enables and the components of it, and we've also been through a brief description of the geospatial reference system and how we can explain that to policymakers. So I'll just take a stop there before we move on to the next presentation and see if there's any questions or anyone's got anything they'd like to share. Thank you.
Maybe I can. Thank you for the presentation. I've just thought about something we were discussing with my colleague here during the tea break in terms of convincing the politicians, because these are the guys we need to convince to have a modern geodetic reference frame. And we were discussing about, especially in Africa, we know we are dealing a lot of, we are getting a lot of revenue from tourism. So there's the protection of these wildlife migratory routes, which is very key. For example, here in Nairobi, we have a national park, but we are having a lot of the citizens having a wildlife conflict, the animals escaping from the national parks and causing havoc. So if we apply this or we use the scenario of protecting or mapping out clearly the migratory routes, it can be quite key in convincing our politicians, especially for the African context. Thank you.
Yeah, I think that's a great use case, and it'll work in Africa, but also around the world to get support, because when people think about Africa, they think about these mass migrations that we all get to see in videos. So you'll get a lot of support and a lot of understanding around the importance of that kind of topic. So I think that's a great one. It evokes a lot of emotion, and that's why I think it's great. Yeah, do we have a comment down here?
Merci pour la.
Yes, thank you so much. Thank you so much for this outstanding presentation. This was truly interesting. Now, when it comes to Senegal, you had showed the current context that we're in. We're currently modernizing our Geodesy networks for a major project. And I see this is a bold project. A great deal of effort will be required, especially managing change, the legislation. And I wanted to ask you a question about making it sustainable, lasting. So we are proposing modernization, but how do we make it sustainable? How do we make it lasting? We have economic models, but in other sectors, but we don't have a reliable economic model when it comes to geodesy. So what we have, for example, we have the PPP projects in the field of toll roads, but why not have this in geodesy as well? It's fundamental. Now, when it comes to stakeholders, I'm looking at the case of Senegal. So leaving or moving from ITRF 2020 and moving to the next version, this is a debate that has been engaged at the level of the stakeholders, and they're, of course, a little reticent when it comes to moving forward to this new version. Now, what guidelines do you feel we could share with them, or what information can we share with them? Because we have seen how useful this can be. Now, you use a specific word, modern. Now, if we're not in the ITRF, we don't have a modern geodesy, a geodetic rather framework. Thank you.
Yeah, excellent points that you make. And modern is, we should talk about that word. I think that's very important. Modern is fit for purpose. So it's not going to be the same in every country. So depending on the business cases you have, you mentioned things like PPP, road tolls. For things like that within your country, you really need high accuracy. So if in the example I'll show you in a moment, when you're going through the development of your roadmap in your country, you should be trying to identify what can I not currently do with the datum that we have? And if we had a new datum, what would that enable? So talking about that gap between what you have and what you don't have, if you can then identify examples of industries or business cases that would benefit from moving from the old to the new, they are the ones that you really need to engage with. And I would recommend you talk to them about getting them to talk to the government on your behalf, so that those industries go to government and say, we want you to do this, and we want the Geodesy team to develop it, because if we have this, it will enable us to do road toll pricing, and it will bring in X amount of $1 million in revenue, which will come back to the government. And then when you might say, well, I need $1 million, and you can demonstrate within 10 years that you're going to bring in $10 million, the government will see that as a good investment. But instead of you telling the government that, if you can get the private sector or the industry to tell the government that, it makes a much more powerful argument. And we'll cover some more of that this week as well. I think this is a good use case. Yeah, Alette, thanks.
That's a correct one. Just a very interesting, I think, use case that I recently learned about. And if you actually think about it, I mean, it's there. But we had the big International Planetary Defense Conference about a week ago in South Africa. And this is all about, avoiding a potential asteroid impact. But what happens if it cannot be avoided? And what they do, because it was in South Africa, they actually looked at a simulation where the asteroid is hitting somewhere in Africa. And they were talking about disaster response and what do we do in case of that actually happening. And I don't think that those people actually think about, modern mapping systems and what would happen. They think they have everything in place, but I think Africa without the modern mapping system, that in a case like that, it could be disastrous. Just another example.
Yes, thank you.
Okay, thank you very much. Yeah, a fantastic presentation. From what Nick just presented, the use cases that from my experience across Africa, I've discovered that most African leaders and politicians are a bit reactive, or they want to be reactive, play a role. They're not proactive. So it's like a scare. Anybody who is in a place of taking decisions must have to use this technology to create a scarecrow for them in the area of 1, security, 2, food, and the third one, disaster. I gave an example in one of the presentation in one place about the disaster that happened in Turkey in 2023. And we discovered that my colleague is here, Dr. Dodo, he's working on some disaster location of GNSS across Nigeria and co-locating them with the seismic stations. You saw that government responded to releasing of fund when they discovered that the places that they are living are affected by some of those early warning issues. So when they see that GNSS use cases or geodetic use cases are tied to what will affect them, either security-wise, food scarcity, and then natural disaster, there is that tendency for them to respond by releasing fund for that research or whatever you want to do. So in Africa, we must be creative in this area. For politicians, they are only interested in things that affect them. They don't understand science. If you try to explain to them the XYZ, they don't understand. So you tell them the disaster that is going to befall them if they don't release fund. So, and the critical areas that you can come with them is to tell them about the scare that is facing them from food security. People are hungry. They will lay them on the road as politicians when they come out for their campaigns. Then 2, there will be security problem like we have in West Africa, Mali, Burkina Faso, Niger, Nigeria. You have militants everywhere that you can use GNSS to tackle them. Then the third one, like I said, disaster. So I think these use cases, when we include them in our presentations to governments, they will give us listening ears. And it's happening already. I think my colleague is here, Dr. Dodo, he will be a witness to that. He's one person that is working on that kind of project in Nigeria. Thank you.
Yeah, just a rider to what Professor Ojigi said. Let me just share with us what we did in Nigeria, and which we are looking forward to such an event happening again. Sometimes for a couple of years, there has been earth tremor coming up in Nigeria, more especially in the capital city of Nigeria, Abuja. So what we did in our Center for Geodesy and Geodynamics, we set up a monitoring system. We started with procurement of some seismometers, and that is one very key thing. There must be that integration. If you are just geodesis, you want to walk alone, you may not find things easy. So we are able to procure some of these seismometers, and we co-located them with the GNSS, and we set them up. So when this earth tremor happened, and we are called upon, and by the time we pick up our data and we do some processing, we add up with an arrow mark of the area, and it was so interesting. And we are able to produce the map, and the Minister of Science and Technology have to quickly have an emergency meeting since the earth tremor. And the funny thing is, where the vibration is felt is more of those areas where those that have it, those with money, the big men, we call them in Nigeria, where the big men, the government power, those in authority are seated. And we told them point blank that if nothing is done, one day your roof and whatever will collapse on you. And with no time, we started seeing government responding. And that's what he's saying. And funds were released. And before I could know what was happening, we were able to procure some sets of GPS core station receivers, which currently we are moving around setting them up. So there must be that co-location. You must look for something that is going to trigger their lives. And I said in one forum that I want more of the earth tremor should keep happening, because the more it happens, the more attention they give to us as geodesists. Thank you.
Right. Yes, Edna, thanks.
Thank you. My question is more on the transformation. You mentioned that one of the reasons why Australia changed, I think, from ITRF 1992 to a more recent, was because it was moving at a fast rate of like 7 centimeters. So, and you mentioned that we have to think about it, even as like some countries which are already on ITRF. So is that like a given time frame? Because maybe like 20 years from now, is Australia going to change to a more recent ITRF at the time? If there is, then what is that time frame? Considering that Africa, we are at like 2 centimeters per year, maybe at a certain amount, like 30 years from now, we should be thinking of, oh, we have to keep doing this, maybe thank you.
It's a good question, and it's not an easy one. It's different depending on the users. So for the Australian use case, because the Australian plate is moving so fast, as you said, 7 centimeters per year, a lot of real-time positioning applications, even that is too fast over the course of a year. So we developed a new static datum, but we also developed a time-dependent reference frame. So the user can choose, do I want to work in 4 dimensions with a velocity, or do I just want to work in 3 dimensions? And any of the regular surveyors in the room or cadastral surveyors would say, I don't want a time-dependent reference frame. I just want latitude, longitude, and height. And a lot of the surveying community, that's why they want a static datum. But there's intelligent transport sector in Australia. They wanted a time-dependent reference frame because they want it to be in exactly the same reference frame as the GPS satellites. So they're using the time-dependent reference system in Australia. So given that we had 2 different users that needed very different applications and levels of precision, we developed both. So we listened to the users and then gave them both, and they can choose which one they want to use. And there's a model that maps between them if you need to convert the coordinates. So in your case, you might make the decision, if we're only moving at 2 centimeters a year, we can just modernize our static datum every 30 years. That might be fine. The distinction is that at the moment, we really don't know what the best thing to do for African countries is because we don't have AFREF. So we can develop a new modern reference system for the countries, but that internal that regional deformation that might be happening, which might affect some of the users who need high precision, we don't actually know what's happening at the moment because it's not being measured. So this initiative around AFREF is really to help us understand how is the continent deforming and moving over time. Once we know that, I think we'll be in a better position to say, okay, if you need this use case, use that datum. If you need that use case, use that datum. So as we collect more information, you can make a better decision, I think. Does that help? Yeah. So sorry, I can't give you a definitive answer, but I think throughout the week, you'll realize some of the things we can do to try and understand how to work our way through that problem, because it's a big one. Yep. All right, I've got to keep moving because we're running behind schedule, but that's okay. I'm happy to have those discussions and questions. The next thing I wanted to quickly show you, and I'll share this on my screen. Some of you might already have seen the roadmap that we shared with you, and we're going to be working through that at different points throughout the week. There it is. So we've got a document, and it says preliminary because you're the first group that we've tested this with. We've put together some ideas and actions for us all to look at, and this is really for you to take away and start to work on. This is your roadmap to work on how you're going to build a geospatial reference system or modernize your reference system in your country. And I'm not going to go through the whole thing. It is available in our information pack. But you can see that I've deliberately set it up in such a way that these are steps that you would go through. So coming back to Edna's question just then around what do we do for our country, the first thing you do is step one is understand what are the needs of your stakeholders. So create a diagram like I showed you before of your current reference system, and then go through things like identifying who your stakeholders are across different sectors and summarize what their needs are, looking at how influential they are and what level of interest they are, and what kind of things do these people need in their country in the future. Then we need, once you've decided what you want to do, we need to communicate why that update is important. And you can see so far we've done nothing that's technical, but these two steps are critical on that pathway. The next one, establish good governance. Again, it's not technical, but unless you have that champion, that high level support to establish a new or a modern reference system in your country, you're probably not going to get past this stage because they're the ones who decide if you're going to get money. Then you have your business cases, as we've been talking about. Create a project plan. And then finally, step 6, we get to something technical, right? You can see how even as you're in this room, you're going to have to work with other people within your governments to go through this process and work out how you're going to deliver on this roadmap. So I'll stop here, and we're going to be working through components of this throughout the week. But please start looking at that. And in particular, have a look at the actions that are there for you to think about and some of the guidance material that you can refer to, and give us your feedback. We are trying to refine this over time. We want to work through this roadmap with you. And hopefully we can get some more input from you to say, I don't understand this, or aren't you missing this step, or we need to do that step. We want to make this document better and better over time. So please give us your feedback. It's not final. Sorry. Yeah, go.
So just to reiterate a point there from Nick, is the agenda this week, as you'll see, is not a fully technical agenda. There are technical elements, but we are building up a lot about the story about Geodesy and the benefits of Geodesy into a nation's industries and public society. So you will see, as we are going through the workshop this week in the sessions, that there will be activities, introductions that are ultimately giving you the skills and the understanding of how to develop a roadmap based on the template that we've given you that is customized for your nation. There is nobody in your nation who knows the geodetic situation and the surveying situation than you, those from those countries. So we want to give you the tools and guidelines and understanding so that you can develop the most optimal, fit for purpose proposal for your nation. Then we will spend time giving you the skills around developing and translating that into actual requirements for funding, how it affects society, how it affects sewerage, emergency disaster responses and so on, because they are the package that you need to secure funding from the governments and ultimately help make your geodetic reference system sustainable in your country. So these are all little pieces building up for it.
Thanks, Ryan.